Hi students, this is AJ sir. Let's study 9th standard ICSE Math 3D. Students, the compound interest formula is applicable in other fields as well. For example, for the growth of industries, we can use this formula to calculate the production after a certain number of years. We can also use it to find the age or the population or the depreciation. Now, depreciation means loss of value. Just like interest is added to the principal amount and the value keeps on increasing. This is called appreciation. For example, the price of gold can increase every year, and the price of the property may appreciate every year. But for machines or certain goods, its value may decrease with time. If you purchase an AC today and you would like to sell it for second hand after 1 year or 2 years, you are obviously going to sell it at a lower price because its value has decreased. This decrease is called depreciation. So let's do one numerical to understand this. In exercise 3D, in the first sum, we see that the cost of a machine is depreciating by 12% every year. So here we will use compound interest formula with a twist. Now what is given is that the machine is valued at 44,000 at the beginning of 2008 and we need its final value, that is the amount, at the end of 2009. So the time period is 2 years, 2018 entirely and 2008 entirely and 2009 entirely. So time period is 2 years. And as you can rightly guess, the amount at the end of 2 years will be less than 44,000 because there is a depreciation in the value. So the twist is that the formula that we are going to use will have the negative sign here. That's the only difference in the formula. Due to which, when we start with a principal of 44,000 and after calculations, we get the amount which is of a lesser value because of the depreciation, and write the final statement as well. That is, the value of the machine at the end of 2009 is rupees 34,073 and 60 paise. Now in Roman number 2, they've asked the value at the beginning of 2007. That is 1 year prior to 2008. So definitely the price of this machine or the cost of this machine would be greater than 44,000. Let's imagine that this machine was purchased in the beginning of 2007 and after 1 year in 2008 its price was 44,000 because of depreciation. So here the 44,000 is the final value. Final value is always the amount, and the initial value will be the principal here, even though it will be bigger than the amount. So the formula is again a depreciation formula with negative sign. Amount is 44,000. We substitute all the values and get the value of P, which comes up to 50,000. Write the final statement that the price or the cost of the machine at the beginning of 2007 was rupees 50,000. Now in the fourth sum, we have to calculate the population. We'll use the same formula. This formula could have been used even to find the age of a fossil because of radioactive decay. But that's not in our syllabus. But this population sum is interesting. It seems that the population decreases by 12% in 1 year, that is 1998. And then it increases by 8% during 1999 in the period of 1 year. Perhaps the population decreased because of migration or some severe epidemic in that town. Find the population at the beginning of 1998 if at the end of 1999 it was 2,85,120. That means there is a gap of 2 years between the beginning of 1998 and at the end of 1999. And this population is the final population, and final value is always A. And they want the initial population, that means they want P. So since the rates are different, we'll have two brackets in the formula. Initially there was a decrease in population, so minus sign for 1 year. And then there was an increase in population, so plus sign for 1 year. We substitute the value of A, we cross multiply after taking LCM, and you'll have to calculate it. Don't just copy it, and we get the value as 3 lakh. Don't put the rupees sign, and just write the final statement that for the population in the beginning of 1998 is 3 lakh. Now in the sixth sum, the difference between CI and SI is given as 7,500. The difference between CI and SI on the principal of 7,500 for 2 years is given as rupees 12. Note here principal is given and the rate is asked. It looks like a very simple sum, but the calculation is challenging. So let's see how to solve this. So we start off with solving and finding the value of SI. Normal formula, P's value is given, T is given. So we can get the value of SI in terms of R, 150 R. Similarly, we shall calculate CI using the usual formula. Substitute the value of P. Here remove the LCM. N is 2 years minus 1. Now here we'll have to use a square formula. In the numerator we have a plus b the whole square, that is a square plus b square plus 2ab. And the denominator is also 100 squared, that is 10,000. After removing LCM we reach this step. Now here 7,500 and 10,000 can be reduced further to give you 3 upon 4. 10,000 and 10,000 can be cut, so we are left with this. Now when we open the brackets, it's distributive multiplication, and the final expression for compound interest in terms of R is this. We can't simplify further. So now the time comes to write the given data, which is CI minus SI is equal to 12. Substitute the value of CI and the value of SI. Surprisingly, 150R got cancelled, making the calculation very straightforward, and square root of 16 is 4. So final answer is 4% per annum. Students, mark the following sums as IMP. The first sum, sixth sum, eighth sum and 10th sum. Now in the eighth sum, Mr. Sharma borrowed a certain sum of money, so the original principal P is unknown, rate is given. After 2 years, he pays 19,360, but his debt is not yet cleared because it's a part payment. Some amount is still left to be paid. So he pays a balance amount, 31,944 a year later, that is at the end of the third year. So what was the original principal amount? So here, let's visualize this sum. The original principal is unknown. After 2 years, he could not repay the entire amount. Out of the entire amount, some amount was left over, let's call it X. And the remaining payment he made was 19,360. Now, on the leftover amount to be paid, interest was accrued further for another 1 year, taking the total time period to be 3 years. And then in the end, he paid totally 31,944. So first, let's find X. This final value will take it as amount. And this X is going to be considered as a principal, and the time period is 1 year. So let's find this amount first. So using the usual formula, A is equal to P 1 plus R upon 100 raised to N. For 1 year, we substitute the values and we get the principal amount as 29,040. That means after 2 years, 29,040 rupees was still left over to be paid. So actually the total amount which he should have paid if he wanted to clear his debt after 2 years was 19,360 plus 29,040. So using that as the amount and P as the original principal with the time of 2 years, let's find the actual value of P. So here we consider the amount after 2 years as 48,400, and using the formula and time as 2 years with the same rate, we calculate 10 square goes up, 11 square goes down, and we get the value of the original principal as 40,000. Now in the 10th sum, the ages of Pramod and Rohit are 16 and 18 years respectively. In what ratio must they invest their money? That means we want the ratio of the principal amounts, P1 and P2. Rate of interest is same, compounded yearly, and they should get the same sum. That is, the final amount should be equal when both of them attain the age of 25 years. Pramod is 16 years old, so he will remain invested for 9 years. And Rohit is 18 years old, so he will remain invested for 7 years. Let's look at the solution. The number of years are 9 and 7 respectively. We calculate the values of amounts using the usual formulae. We don't know the P1 and P2. Now we know that the amounts should be same in the end. So A1 is equal to A2. So let's equalize both these equations. And we want the ratio of the principals, that is the ratio of the investments. So P2 goes down and this goes down here. We reach this. Now since the bases are same, we can cut the exponents or subtract them. So 7 goes away and 7 goes away. Only a square remains in the denominator. And if we do the reciprocal of this, because denominator goes to numerator and squaring, we get the ratio as 400 ratio 441. Make sure the final answer is on a ratio and write the final statement as well.